In this video, I'm going to review the properties of exponents. In the 8th grade math class and the Algebra 1 class, I actually go over each of the properties of exponents and where they come from. For the Algebra 2 class and college algebra class, all I'm doing is a review as a refresher. If you need any more assistance on properties of exponents, please let me know and I will go over them with you. Or you can go back and watch the 8th grade or Algebra 1 videos to go over how these are derived. So the first property we have is the product property. Quick thing to note are all bases and denominators are not equal to 0. That way I don't have to write that every single time. So product property, if I have a to the m times a to the n, notice these have the same base. I add the exponents. An example here would be 3 squared times 3 to the 4th is equal to 3 times 2 plus 4, which is 3 to the 6th. And you can directly go from this first part to the last part. I do not need to see the intermediate step, but for some of you it may help. That's the product property. We have an associative quotient property. If I have the same base, I will subtract the exponents. An example here, x to the 7th over x cubed is equal to x to the 7 minus 3, which is x to the 4th. From here, I have the negative exponent property. If I have a base raised to a negative exponent, it is the same thing as the reciprocal raised to a positive exponent. And in this case, I haven't shown you yet the quotient property. It's also the same thing as 1 over the base to that first power, if this happens to have a 1 when you do the reciprocal there. And this works for anything. So if I have x plus 5 to the negative 2, that is the same thing as 1 over x plus 5 quantity squared. I have the 0, 1. A to the 0 is 1, but again, my base cannot be 0. Okay? And by definition, that's a definition, and we can get it from using this property. And 0 to the 0 is undefined. 0 to any other power other than 0 is 0, but 0 to the 0 is undefined. A product raised to a power is the same thing as raising each of the items to that power. So for example, 5x quantity cubed is equal to 5 cubed x cubed, which is 125 x cubed. Similarly, I have a quotient raised to a power. I take the power of each term of the quotient. Example here, let's go 2 over x cubed is equal to 2 cubed over x cubed, which is 8 over x cubed. And the last one that I did not cover in Algebra 1 or 8th grade math absolute value of something squared is the same thing as squaring the absolute value of that something, which is going to be identical to that something squared. For example, absolute value of -2 squared is equal to the absolute value of -2 squared, which is equal to 2 squared, which is 4. I know this is a simple example, but when we get later on in the college algebra class, or when you take college calculus or something like that, this will come into play more readily. Again, this was just a review of the properties of exponents. If you need to know where these come from, you can go back and watch the 8th grade math or the Algebra 1 videos. But you do need to be able to use each one of these properties of exponents.